Hello class. In this video, I'm gonna talk about floating points, arithmetics, and the problems with comparing uh, floating points. So let's go ahead and take a look at this example. First of all, I'm gonna show you the code, and I will explain this code, and then I will run the code, and then you observe the output, and then we will analyze from there. So first of all, let me comment out this code down here so that we don't get distraction, and then I will uncomment it later. So I do save, and let's take a look at this code. I have a double variable x, and I assign x with the sum of 10 of these, 10 of 0.1. So if you are adding 10 of these, what do you get? You should get 1, right? Because you can count, you can count. I have exactly 10 of these. So they should add up to be 1.0, right? And then I have an if statement. I say if x equal to 1.0, I say this is the first if, and x equal 0.10 is true. Otherwise, or if it's not true, I'm going to see out x equal 1.0 is false. So let's go ahead and run this code. What do you think? What do you expect to see? Do you expect to see this cout on line 26, which say x equal 1.0 is true? Or do you expect to see this? Commonly people will say, this is what they expect to see, right? So let's run the code. Uh-oh, that is not what you expect, right? Let me rearrange the window so we see both the output and the code at the same time. This is the output from here, line 23. That is easy, straightforward, right? Now, the confusing part, you expect to see this, right? However, what output is this? Line 29, x equals 1.0 is false. That's what you see right here. Can you see any problems with the code? You can take a look at this comparison and you say, I don't see any problem with this if statement and this comparison, right? So what's wrong? It looked correct, but the result is not what you expected. So the problem is when you declare a variable as double, the representation of double inside the memory is not exact. So you probably learned from the first class that everything, all the digits in your C++ program is represented as binary number in the memory. So X is declared as double right here, but in memory, it had to be converted to binary number and stored as a binary number. And if you learn how to do the conversion from floating point to binary number, you will figure out that the representation cannot be exact. And that's exactly what's the problem right here, because we are comparing x with 1.0, and that's the exact comparison. So when C++ sees this, it generates instruction to compare bits by bits of the content of variable x and the value 1.0. And unfortunately, like I said, the representation of floating point, especially when you declare the variable is double, which has more precision than float, the comparison, the representation is not exact. Therefore, this comparison is false. X is not exactly like 1.0. And then you may ask the question, huh, if this is false, how do I make the comparison that I can make a conclusion that X is 1.0? So the solution is, instead of compare exact to 1.0, how about we do this? Let me close this run window and then uncomment this code and then rerun the code so that you can see what the solution is. So instead of compare exact, we say, I am comparing X with 0.999. You can throw in a whole bunch of 999, it doesn't matter how many. The more you have, the better, the higher precision, but it shouldn't matter. So if X is greater than 0.999, and remember this in AND condition, and X is less than 1.00, a whole bunch of zero, and then somewhere you throw in the digit 1. So if X is between 1.00001 and greater than this, you make the conclusion that X must be 1. So that's the solution. So the lesson learned here is never use equal comparison on float or double. Sometime in float data type, you are lucky that your equal comparison works. But most of the time, double never works for equal comparison. So let's run this code again and see if this fixed our problem, right? Build and run. Bingo, that's what you're looking for. The output from here to here, the first if is produce this output, which is wrong. We say it should be 1. So we use the different comparison right here. I distinguish between this if and the first if by saying this is second if. So the output right here, it's a second if true X is 1.0. Second if true X is 1.0. And line 35 is not producing output. So we are sure that line 33 generate this output, and that's how we make a conclusion that X is 1.0. You see the difference between the two? So for many of your homework assignment, if you use double or float, you should not use the exact equal comparison. You need to use this kind of comparison where it's greater than some numbers and less than another numbers. So in the combination, if you look at this, if it is greater than 0.99, less than 1.00001, so X must be 1. So that's how you fix this problem. And this is not a C++ problem. This is a general binary representation problem. So regardless of what language you write your code, I see the same problem with Java and Python. So it's not a specific C++ problem. It is a general problem with floating point comparison. And that is the end of this video. See you in the next video.